this module is on linear functions, okay? Linear, meaning it's going to look like a line. So on page 5, did I say 5? 6. Page 6. Yeah, we need to get these back together. So it says, Illabel's Electric Company charges 15 cents per kilowatt hour, plus a basic connection charge of $20 per month. Find the rate of change. Okay? So let's take a look at this. This says per kilowatt hour. So 15 cents per kilowatt hour. Over here we have a table, kilowatt hours. So at 0 kilowatt hours, our bill was $20. Okay, what is that $20? What does that represent? The basic connection charge. Okay, we'll come back to that in a minute. At 100 kilowatt hours, it says we have a monthly bill of $35. And it says for 200 we have $50, $595, 1,000 we have $170. And we also have this handy dandy graph, which happens to be a line. Okay? Find the rate of change. What do we mean by rate of change? What is the rate of change? What are they talking about there? Any idea? Rate of change. Well, talk to me about this line. What can you tell me about this line? What, if anything? It is linear, yes. Okay, that's good. That's a good start. So this is a linear. Is it a function? Yes, it is a linear function. How can we tell if something is a function? A linear function? The vertical line test, yes. Okay, so vertical line test, if it only crosses in one place on your graph, then it is going to be a linear function. Okay, what else can you tell me? Looking at the line graph, just the line graph. Anything at all? Let's see. We have here, we could talk about this in graph form, which we do have a graph. Okay. We also have a table. And what else might we use to describe what's going on with this actual linear graph? An equation, yeah. So how could we find an equation? Is there any part of this equation that we might know? Ah, 15 cents per kilowatt hour. So you're saying this is what part? What do we call that? Do you know? You're right. It goes in front of the x. What do we call that in front of the x? Slope. Yeah, this is your slope. Okay. And the basic connection charge of $20, what's that called? Yes, y-intercept. Okay. And where do I find that y-intercept on this graph? On the y-axis. Yeah, right here. So there's my y-intercept. Okay, you might be adding some of this stuff on your papers or not. So can we write an equation here? What would that be? 15 cents x plus 20. Okay, is that an equation? We're really close. Equals 70? 170? Is it always going to be 170? No. She is really close. Help her out. Equals y. Yeah, because it varies, right? So this takes the form of y equals mx plus b, where m is your slope, right here. That's your slope. Your b here is 20. That's your y-intercept. And what goes in here for this x and y right here? Huh? Yeah. Say that one more time, a little louder. Do you guys have lines? What is it? Does it say anything on the lines? So you can do whatever. Yeah, I'm just writing it down.
Yeah, it says at the top of the page, for this situation, write a journal entry on the next page explaining how the rate of change will be identified.
Okay. So the rate of change, how it could be identified is we're saying it is 15 cents per kilowatt hour. That is the amount of the change. Okay, that's one way to find it. But what are my x and y values here? What could they be? What could they be? I mean, we all know y equals mx plus b, and maybe you even know the slope and all of that, but what is this x and what is this y? Aren't they each of the individual points along that line? Yeah. So you stick in any x, y point, and that's going to make that equation true. So x and y here are the coordinates of any point on that line. The coordinates of any point on that line. Okay? La-di-da-di-da. Let's see. Another way that we might find that rate of change, okay, is you are going from $20 to $35, right? How much of a change is that? $15. $15 by taking 35 minus 20, right? And this is over 100. So if I take 15, let me write this in something darker, and I divide it by 100, if I take 15 and divide it by 100 this way, that gets me that 15 cents, okay? So that's another way to show this difference in slope on a table, is finding the difference. Here again, it is $15 over 100. But over here, what's the difference here? 50 to 95, that is a difference of how much? $45 over 300. Well, if on your calculator you take 45 over 300, okay, as a decimal, that again is going to simplify to 0.15. So one way to find the, what do they call it? The rate of change is to put it in equation form. So that's the first way. Put it in equation form. Find your slope in equation form. A second way is to look at your table, okay, and find the slope of your table, which is the difference between the bill over the kilowatt hours. And a third way, how do we find slope in general? There's a formula. Check back at the very first page of this section. Maybe on page 3. Yeah. Y sub 2, is that, you said something like this? Yeah. The change in y over the change in x. This is equal to your slope formula. So if we look at a couple of points like this, change in y. Let's see, I kind of made a mess of it, but that is the point 50 to 100. That is on the line. And if I look at this point, well, shoot. Can I tell what that is? Not very easily. Let's try. Let's see if it's 95, 500. Whoops. 95 and 500. Change in y. Okay, so I'm going to make this my 0.2. I'm going to make this my 0.1. So I'm taking 500 minus 200, those are my y values, divided by 95 minus 50, these are my x values, and I get 300 change in y over 45. All right, what is 300 divided by 45? Who's got a calculator? Hello? Change in y over the change in x. I did do the right way, didn't I? Change in y. No, I didn't. Oh my gosh. Why didn't you guys tell me? How embarrassing. What is my x value here? I got them in backwards. It should be 250, correct? Your x value here is 200, and the y is 50. So my 0.2, I was like, that is not going to work, is 500 and, what do we say, 95? Okay, so we're going to flip these. These should be flipped, which is 45 over 300, which is much better. If I divide that by, geez, I don't know, 3 over 3, yes. How'd you get in here? Door was open? Okay. Okay. I get 15 out of 100. 15 hundredths, which is my slope again. 15 hundredths or 15 hundredths. Okay? So there are many ways in how to find that rate of change. By doing it with the graph itself, by using the table, or by using the slope formula. Okay? More than you wanted to know, right? Any questions about that? And I am recording, so you can go back and watch and listen to this again. All right, let's turn to the next page. Talking about peaches and plums. Peaches and plums. Yeah. Restroom? Oh, go back? Yes. All right, take a look at that page about peaches and plums. Yes. Peaches and plums. Does everybody know what a plum is? Has anyone not ever had a plum? Some people have never had a plum. It's kind of like, I don't know. It's kind of like a peach, but it's purple, kind of. Or a nectarine that's purple. Okay. Yes, Miss Dee. Uh-huh. Oh, okay. She just got the paper, but I can release her now. Okay. All right. Thank you. Bye-bye. Miss Nyla, they're looking for you to leave now. All right. Did we get that all done? Okay. So peaches and plums. Which costs more per pound and how do you know? So this is always kind of a little bit shortened. Graphs below show the cost Y of buying X pounds of fruit. Y. One graph shows the cost of buying X pounds of peaches. The other cost shows the cost of buying X pounds of plums. Which kind of fruit costs more per pound? Which costs more per pound and how do you know? Which costs more per pound? Peaches? How many say peaches? Everybody say plums? How do you know? You're right. Peaches do cost more. Kaylee? Okay. Yes. So the line is more steep. The line for peaches is more steep. Which means what? Okay. Which means the price is increasing at a faster rate. All right. What if you didn't know that? Okay. Let's say we didn't know that. And so maybe I put some of these down here at the bottom. Okay. So let's say this is 1, this is 3, this is 5. This is the number of pounds of fruit that I have. And let's look at what this might be. If I find 3 pounds of plums, okay, that is showing at this cost, right? Whereas if I show 3 pounds of peaches, that cost is much higher, okay? So you can also use these different lines to help you figure that out, okay? So peaches cost more. It has a much higher or a much steeper line, which means it's going to be costing more. All right, let me see what this says. Go back. Okay. I like doing this because this gives a visual to some students. Some students don't understand, oh, it's steeper. That means it costs more. Well, again, if you actually put in points, you can see if I get 5 pounds of fruit, peaches are going to cost a lot more. So I like doing that too. All right, let's take a look at this one. Bananas cost less per pound than peaches or plums. Draw a line on the graph that might represent the cost of buying bananas. Draw a line. Show me bananas. I feel like a talk show host. Show me a line for bananas. Bananas cost less per pound than peaches or plums. Draw a line on the graph that might represent the cost of buying bananas. Okay. Have you got your lines? Devinus, you got a line? Got a line? Okay. So, bananas. What could it be? Could it be the black line, the blue line, the red line, or the green line? Red line. Okay, so we're saying this could be bananas. Does it have to be that exact line? No. How many different lines could we have for this answer? 2? Could it ever be the black line? No. Can't be this line ever. Could it ever be the blue line? No. Could it ever be the green line? We're talking about cost of bananas. A real life problem. No. Technically, no. Mathematically, yes, but technically, no, since we're talking about real life. Could this be a line for bananas? Could this be a line for bananas? Could this be a line for bananas? Yeah. How many lines could I have? 3? Infinite. Yes, you could have infinite number of lines because you can always find a point that is even smaller. Okay? So, infinite number of lines, not just one line, but it has to be less than plums and more than the x-axis. All right? Any questions about that? All right, we are moving right along. You guys are doing great. What is the independent variable that causes the change in these prices? What's the independent variable? Means it doesn't care what's happening on the other one. It is what it is. Yes, so the independent variable is always going to be whatever is on your x-axis. This is your independent variable. Okay, which means your dependent variable is over here, the label for the y-axis. All right. So once you have your x, that determines what your y value is. Any questions on that? Okay. All right. So that's all I have for today. Again, our test is currently scheduled for January 28th. You could start looking at homework number 1, but you could also wait, okay? I guess that's it. That's it, folks.